All right, so welcome back to the second part of the class notes for non-contact forces. Look here at the screen, this is where we left off. Where we had an introduction to what a force was, push or pull, and that there were two types of forces, contact and non-contact forces, and we were going to start with non-contact forces. And so then we talked a little bit about what a non-contact force was and the three types of non-contact forces here on this slide, all which you should already have in your notes, on your guided notes. So have that document ready to go too. If not, pause the video, open it up, come back, and let's keep moving. Okay. So electrical forces. Electrical force is a non-contact force. You've gone through at this point, hopefully, and you've finished the electrical force sim. And so I'm going to reference back to that lab a bunch. So if you haven't finished that lab yet, even if I would suggest waiting on the notes until you finish that, because I'm going to keep referring back to that. And I think that is going to make more sense of what you saw in that lab compared to what we saw here. If not, that's fine. If you want to get the notes done because you need to get it done, go ahead and get it done. But I would then highly encourage you, after you're done with the lab, to come back and look at this video one more time just to make sure that you're making the connections between what I'm talking about here through the notes versus what you saw on that sim. All right, so we talked about the importance of what a field was. A field is this region of influence, right? Kind of that funny saying, that region of influence for electric fields and all non-contact forces. But the electric field is this region of influence that's happening for anything that has an electric charge, okay? One of the discoveries that you should have found out in that lab is that the strength of that electrical field, or what's going to be referred to as our electric potential energy, but the strength of that field decreases as you get further away from the charge. Okay, and so in other words, that means increasing distance. So as you get further away, the distance is increasing, and so that's what we are seeing up here in the graph up here. Okay, so make sure you're taking a look at that here. This is right here. That's what that's showing. Okay, it's showing that as you get further away, it decreases, and it decreases at a decreasing rate. And depending on the science class, depending on what math class you're in right now, that is either a new phrase to you or a phrase you've heard in math class before for this type of graph. It's decreasing at a decreasing rate. And so what that means is that right at the beginning, we see a pretty steep line here, a pretty steep slope, which means that it's decreasing rapidly at the beginning. But as you get further and further away, yeah, it still decreases as it goes further and further away. But the amount that it decreases starts to slow down a bunch. So it decreases rapidly at the beginning and decreases at a slower rate the further you get away. Okay. Oops. So it's decreasing rapidly with increasing distance. So that is one of the things that you discovered in that lab. And in fact, your graphs that you made should have looked something similar to this that you guys created for number 5 on that doc. Okay, it should be a sloped line. It should not be a straight line. It should be a sloped curved line like this to show that it's decreasing at a decreasing rate. Okay. Okay. The other thing that you were supposed to hopefully discover with this lab is what happens with the two charges, okay? And I'm going to see if I can move my screen here a little bit so that we can see that, because that's going to be important. All right. One thing that you should have seen is that like charges repel each other. So that's one thing. Like charges repel. So if you have two positive, those are like charges, so they repel. Two negatives, those are like charges, so they repel. Or in other words, they move away from each other, which is what the second part of this diagram is showing. If you have opposite charges in the field together, then the opposite charges are actually going to attract. And that's where you've probably heard that saying before, opposites attract. Well, here's where it comes into play in science. You have the opposites that attract here between the two opposite charges, in this case, positive and negative. And you notice the drawing of the electrical field here in the first drawing, different than this one here. Now, part 3 of the lab, which was the part that you were just supposed to put the things onto the field on the sim, and there was nothing for you to do because I was going to have you make drawings. And I started looking and showing you some of the stuff, but I want to really draw your attention to it here, as this is the end. This is the only slide that we're doing for notes today. So take a look at the picture down here, and let's look real quick here at what we have going down here. It's not giving me any of my tools. Why is it not giving me any of my tools? Give me my tools. Okay. Well, it's not giving the tools. All right. So what I'm going to have you really focus in here, and I'm going to actually get rid of my screen so you guys can see it. Always look in between the two charges. And that's where you're going to see the difference. Okay, so always look in between the two charges. So I'm going to look in here between the two charges. I'm going to look in here between the two charges. When they are like charges and they are repelling each other, you will see what I have termed the shield of repulsion. Okay, the shield of repulsion. So the shield of repulsion is this kind of shield that you see right here, right? It kind of looks like a shield or a star. Okay, this open space right here. This means that they're repelling from each other. And look, the charge comes out, and instead of going right to the other charge, as it comes closer to the other charge's field here, they move away from each other, right? They don't touch, and so they move away. Notice the difference here when you have opposite charges and how they attract. Look here between the charges, you no longer see the shield of repulsion. That's not there anymore. It's gone over here. You now see the charges going from one charge to the other. You're going to see from the positive to the negative. Okay, and that's just based off the field, and that was something you should have seen in the lab as well. So you see going from here to here, and in this area, you don't see this empty space, the shield of repulsion. You now see it moving from positive to negative. And so that's a big difference with the field drawings. Okay, and I'm going to give you a little hint here. Whatever we do for some sort of quizzes, maybe I'm going to do a Google form quiz, something like that, where that represents what we're going to do for an assessment or a test, is I'm going to have some drawings on here like this. And I'm not going to tell you what the charges are. Okay, they'll just be blacked out dots. And based off of the field drawing, you have to tell me whether they are like charges, and you would then see a drawing similar to this, or opposite charges, where you would see a drawing similar to this. And again, the way to do it is to look in between the charges, look for the shield of repulsion. If you see it, then you know that they're like charges. This is the same. If these would be negative and negative charges, two negative charges, we would see the same exact drawing. The only thing different would be that the arrows would be pointing in instead of away, but you would still have this shield of repulsion here. Or if this was shaded in dark and this was shaded in dark, and you saw no shield of repulsion, then you'd be able to answer that that must be a field with two opposite charges. All right, so that's it for electrical force. Hopefully that makes some sense of what you saw with your electric force sim. This is it for the notes for today. The only thing that you're moving on to next then is to go on to the gravitational field lab.